So for this video, we are going to start with another second major type of AHU, which is single duct variable air volume. So SD and VAV, SDVAV. That's how usually we'll have notations on research papers, on in textbooks everywhere. So that's why it is important to understand it. It will be known as SDVAV. So in the previous video, I had covered the structure and the calculations for single duct constant air volume. So with respect to that one, the variable air volume has slight amount of changes, and where over here in the earlier video where we had known, or in the SDCAV, we know that the temperature, loads and the volume flow rate in our AHU is given. But for this, what we only have is the temperature in the zone which is required, that's the comfort temperature, and the loads, while the air volume which is going to be circulated in the AHU will not be known. That's one of the quantity which we want to calculate based on some given values, obviously. So let's first make the AHU schematic, which is very important for us, and then we'll go into other calculations of the amount of air volume, and the temperature calculations will still remain the same as what we had in the SDCAV, that was single duct constant air volume. So starting with this, we obviously have an outside air which is coming, whose temperature and relative humidity is known to us, right? Then we have some return air which is coming, RA means the return air, over whose the temperature and the relative humidity will not be known. So this is the temperature of return air. And there is some exhaust air. Now the outside air and the return air gets mixed up, and it is called as the mixed air. The mixed air flows through a preheat coil. This is a preheat coil, after which the air temperature is noted as TPH, T subscript PH. Then the air goes to cooling coil. At the exit of cooling coil, the temperature is called as TCC, T subscript CC. Then we might have a fan, which is called as a supply fan. And this all setup can change. We can have a supply fan before cooling coil, after cooling coil, it doesn't matter much. Only the calculations part will change a little bit. And for the supply fan, there could be some temperature rise because of the velocity change of the air. From the supply fan, we'll have some air supplied to different zones, and these are the reheat coils, and it could be supplied to n number of zones. So these are reheat coil. This is reheat coil. Then this could be the zone 1 where the air is supplied from the AHU. There could be n number of zones, as I said. This could be the second zone. And after the zone, the air is taken out as return air. That's from the exhaust or vents from my zone. So that's how the common setup is. We can have an extra return air fan which will push the air from the zones to the outside and to the return duct. Additionally, the only change with respect to single duct constant air volume over here is, over there we had the constant amount of air volume flowing through the AHU, all the ducts. Over here it is not the case. What we have is, for the zones we'll have supply temperatures. T1 and the comfort temperature T1 and T2, and the sensible loads, latent load in each of the zones known to us. Based on that, what we have, we will calculate the supply temperature as 1, supply temperature of the second zone. And based on the supply temperatures, what we have is, we want to calculate the amount of volume which is going to flow. So earlier the amount of volume was kept constant, hence the supply temperatures were varying. But over here it is not the case. We can change the amount of volume which is going to flow. So what we want to do is, using the same energy balance, what we calculate is, this is the supply duct, and the temperature of air over here is noted as Ts. So this could be the TCC plus delta TSF will be Ts, right? Now my flow volume calculation will be, to first zone, the amount of air which I want to supply is given by this Ts. So let's say this is the jth zone. For first zone, the J will be 1. So for the jth zone, I'll give the value of sensible load divided by 1.08 into my Tj. Let's say this is jth zone, whose temperature requirement is Tj, and my supply temperature is constant, which is Ts. So using this formula, I can find out the value of the zone supply volume flow rate. If my supply volume flow rate is very low, then it is the second case, and in that case, what we want to do is, we'll have some minimum flow ensured in the building, and then that zone, if this zone has a very low value of Q dot, this is the sensible load in my in that zone, and if that sensible load in that zone is very low, then the case would be that the volume flow rate required will be very less. But if we want, we want to minimize, we want a minimum value of volume flow supplied to that zone, because to maintain the ventilation and fresh air which is coming, and hence in that case, my volume for this zone, if less than the minimum set, this could be a set value, this could be this must be a given value to you. If this is the case, then what I'll do is, I'll make this specific zone work as constant air volume system. Otherwise it will flow as a variable air volume system. So for this zone, we have calculated the value of the Vj, and all the other temperature calculations and the load calculations. So I may have a return air load. My return temperature will be calculated based on that. My return temperature is known, outside air temperature is known. So based on that, I have a formula which is TMA equal to TR plus XOA, which is the fraction of the outside air divided by the amount of total air. Total air will be the summation of all the airs which is supplied to different zones into T outside air minus TR. Now the pH preheating coil only works if my outside air, my mixed air, is at a temperature lower than TCC. If it is not, then the air just passed by. Then in the cooling coil, my mixed air, which is flowing from there, will be cooled down to a temperature of TCC, which is a set point temperature. And that's how my flow works. I hope you have understood and you are clear with the calculations. And I'll make much more detailed video on all the different types of calculations and taking an actual numbers from one of the buildings which I have worked on recently. Thank you.